Hello everybody, this is Tommy and welcome back to my weekly physics explainer videos, and today we're going to be going over problem number 47 in chapter 19, which asks, your 300 milliliter cup of coffee is too hot to drink when served at 90 degrees Celsius. What is the mass of an ice cube taken from a negative 20 degrees Celsius freezer that will cool your coffee down to a pleasant 60 degrees Celsius? So essentially what's going on is that when we have a 90 degree cup of coffee and we are to add a negative 20 degrees Celsius ice cube to it, the heat energy from the cup of coffee will enter the ice cube and it will begin to melt, and we want to find the mass of such an ice cube where after it's done melting and the melted water will increase in temperature up to 60 degrees. We want to find the mass of an ice cube where that will happen, where the equilibrium is at 60 degrees Celsius. So in order to find out how much energy will be lost by the cup of coffee, we can essentially just use the heat energy equation over here, and we know that we can essentially assume that like a cup of coffee is basically the same weight as water. So if we convert milliliters to kilograms, we can get 0.3 kilograms. And we know that this will be the specific heat of water. And the total change in temperature will be from 90 to 60, so it's going to be 30 degrees Celsius. And after we multiply all of them, we can get 37,800 joules. And that's how much energy is going to enter the ice cube from the cup of coffee. So when we put the ice cube in, it's going to increase from negative 20 degrees Celsius initially, since that's how it was when it got out of the freezer. So it's going to be the specific heat of ice multiplied by the mass of the ice cube multiplied by the change in temperature, which is the change in temperature is going to be 20 degrees, because when it gets to 0 degrees, it will have to change its state from a solid to a liquid. That's essentially what it means to melt the ice cube, and this is going to be how much energy that it's going to take to melt a single kilogram of ice. So this is the energy to increase the ice cube from negative 20 degrees Celsius to 0 degrees Celsius. This is going to be the energy to change the state of the ice cube from solid to liquid, and this is going to be the amount of energy that it takes in order to heat the water up to 60 degrees Celsius after the ice cube has been melted. And of course all of these will share the same mass, since no mass is lost, and the change in temperature here is going to be 60, and it's going to be using the specific heat of water because now it's water, not ice. So, and we know that the total energy that is entering the ice cube is going to be equal to the total energy that is lost by the cup of coffee. So we can plug all of these in. So we can plug all of these numbers in to essentially get 0.06 kilograms. That is, of course, after we isolate the mass and set it to one side of the equation. And the final solution after plugging in all of these numbers is going to be 0.06 kilograms. Thank you.